Hello, everyone. I hope you all had a good lunch break. I had hot dogs, so highly recommended. A very quick note about me, who I am. I'm Kat. I live in Bristol in the UK. I'm originally from Poland, with a P, not H. Never been to Amsterdam, but I'm going next week. And my slightly odd Twitter handle is my Polish name, so it's up there. Let's just test the laser pointer. It works. If you want to tweet me any questions or just have a chat, then by all means, feel free to tweet me. So I'm a software engineer, and my background is in PHP, and I started doing Go about 2 and a bit years ago. So I by no means I'm an expert. I'm probably somewhere at the intermediate level. And that's actually where the idea for this talk came from, because when I was getting started with Go, the structuring of Go apps is something that sort of was one of the first questions that I had. And then as I was doing Go over the years, I've had a lot of people come to me when they were starting Go and ask the same questions, which are something along those lines. So, probably when you're first starting out with Go, and even after you've been doing Go for some time, you're like, should I put it all in one package in a flat structure? But then when you're writing a bigger app, then that might kind of get a bit big and unmanageable and sort of getting out of control. Or maybe you're like, well, I'll start with one package, and then I'll just split out into other packages over time and just kind of see how it goes and wing it. Or maybe you're like, maybe should I use a framework, and that will give me some structure to work with. I also thought, when I was completely new to Go, and this is like that was my newbie moment, I was like, well, can I do like object-oriented programming in Go? Or like, especially if you don't have much experience with C, that's kind of a new world to you. And then I was like, oh, can I use DDD, domain-driven development in Go? Like, where do those concepts fit into Go? And then later on, we've all started moving towards microservices. So then you're like, well, should I keep it a monolith? Should I try and start from scratch with like the microservice architecture? And then how much should be shared between each packages? Because you write your packages, and then you're like, well, should I keep them completely separated? Should I always duplicate everything? What is OK to share? What's not OK to share? All those questions. I haven't used a lot of frameworks, so I'm not going to talk much today about frameworks. There is Go Kit, and there is Go Buffalo, obviously. And I think it's a great way to start if that's your kind of thing. Like, they will help you out. They will force you some structure upon you. But that's also the slight downside. Like, they won't be that flexible. Like, you'll just have to go with whatever the framework forces you to do. And I personally prefer to like learn from first principles. So like first, kind of think about the general principles, and then maybe come back to a framework, and then having that understanding of the basic design patterns and like the common industry standards, it then helps you to judge the framework and helps you figure out why they've done something the way they did, and is it a good framework, is it maybe not a great framework, and that kind of thing. So we're not going to talk about frameworks too much today, because that would take a long time. And we're just going to focus on generic rules and specific first principles. Why do you care about structure? Like, some of you might be thinking like, oh, let's just it doesn't really matter, like it's not the main point in programming. Well, Dave Cheney said this at Golang UK 2 years ago. If Go is going to be a language that companies invest in for the long term, the maintenance of Go programs, the ease with which that they can change, that will be a key factor in their decision. And I think that extends to companies. Like, if you're trying to pitch Go to your company to use it for your next project, then certainly after you've written your first project, your coworkers in the company is going to look at how it went and how does the app look like. Are you happy with it? Does it feel like it's future-proof? It's going to last a few years, or has it been just a completely failed experiment and is just a mess? And also personally for yourself, like if you're to stick to Go long term, you kind of want to feel good with it. You want to feel confident that what you're doing is right and you know what you're doing. So I think that's structure is important, even though it might seem like not the most important thing in programming. I think it really is, because it just makes your life easier if you have an idea of what you're doing. So how do you get to that good structure? It's one of the rarely mentioned issues, to be honest, in the Go community. At least when I started out, I couldn't find that many resources on it, and everybody seemed to have a slightly different answer and just personal preferences, most of the way. Those who knew C design patterns, I felt like they had a head start because they were all familiar with it. Those of us who came from OO backgrounds, maybe a little bit less. And the language itself doesn't give you that many hints. I mean, if you look at object-oriented languages like Java, you've got your classes, you've got your objects. It kind of just forces you to then think about inheritance and polymorphism and all of that. So you kind of get some guidance from the language itself. Whereas Go is kind of a bit more bare bones, which is a great thing about it. Personally, I love it. But it doesn't really sort of guide you in any direction. It just leaves it up to you. And I think that's really fun, because it just allows you to experiment and see what works best. But the downside is also that it can be a little bit hard to get started with absolutely no clue where to go next. But luckily, I think especially in the last 2 years, we've had some patterns emerge. So I'm going to go through all the patterns and hopefully give you a summary of where we are today and what seems to be the recommended way to structure your apps. But before we get into this, let's think about what makes a good structure. What are the goals? What's the holy grail that we're going for? So a good structure, I think, first and foremost, needs to be consistent. There's nothing worse, and I think we've all been there. There's nothing worse than working on an app which some part of it is from 2 years ago and it's in one style, and then some other part that is newer is in a completely different style. It's just a mess. So a good structure is consistent. It doesn't matter how good or bad it is, at least it's consistent. Easy to understand, easy to navigate, easy to reason about. Basically just makes sense. You look at the code and it makes sense to you. Easy to change, fairly loosely coupled so that you can do refactoring and you can easily add, remove things, change things without having to spend 2 days at a time doing it. Easy to test, so obviously help yourself out and make your life easier. And then I love this quote from, it's attributed to Einstein. I think it was one of his coworkers who actually paraphrased what Einstein said differently. But hey, he said, as simple as possible, but no simpler. And I think that just plays really well with the general idea of Go. It's as simple as possible, but not simpler. So have in your structure, just have the absolute minimum, everything that you need, but also the absolute minimum of what you need. Don't have anything that you don't need there. And then the design, ideally, the design of your app should reflect how it works, right? That's kind of the general guidance. And then I think that the structure should also reflect the design exactly. So if your structure reflects your design, and the design reflects how the software actually works, then your structure reflects how the software works, which makes it all easier to understand. And we've probably all been there where it is kind of important to think about those things up front, because once you pick a structure for your project, you're usually stuck with it. Maybe some little refactoring is possible, but usually you can't easily migrate from one style to a completely different style without pretty much just half rewriting the app. So I like to do talks where I actually give you some examples of what I mean, because I think it's just easier to then sort of pass on the message. So for this talk, I thought we're going to try and write a simple app, and for the lack of better ideas, it will be a beer reviewing service. So imagine you're asked to write a beer reviewing service where the users can add a beer, they can add a review for a beer, and then they can list all the beers, or they can list a specific beer, or they can ask for reviews for a specific beer. So that's your functionality spec. And then for simplicity, forget about updating or deleting. I've also, you'll see that later in the code, skipped some error handling just for simplicity and just to focus on the structure. So obviously don't do that in real life, but for simplicity, I've skipped some of the things. And then also, from the more techie requirements, we want the storage to be either in memory or a JSON file. And ideally, you should be able to pick which one you want at the start. And then also, we want that service to be able to populate itself with some sample data to start with. So stripping that down a little bit, let's think about what are we actually doing? Like, what is it that we're talking about here? So starting to think about our domain before we even jump into the structure, because that's one of the things that is really, really good to do before you jump into the code, is think about what you're dealing with, essentially. So here we know we've got some beers, like as an object, as an entity. We've got a review. We've got storage. We've got in-memory storage and JSON file storage. It all sounds like an API, because it's like get beers, add a review. So it's probably going to be an API. And then there's the sample data that we somehow have to provide that mechanism. So it sounds like maybe it's a separate command that you'd like to be able to run aside from the server to like populate it at any point. So let's look at some of the common ways we might like to structure this app in. And let's start with the most obvious one, which is stick everything under the same directory. So let's have a look at the flat structure. This is one of the ideas. Obviously, this isn't how you should do it. This is just how you could do it. Some of you might have different ideas for how you would go about it. But this is kind of the most intuitive. Like, let's just have a go at it, and see where we end up. I think flat structure is a good place to start if you don't really know what your app is going to look like yet. Like, it's a good starting point, I think. And I think it's still perfectly valid. It was something that, like Peter was saying earlier, that it's perfectly valid for small projects. There's nothing wrong with keeping it simple, all under the specific root directory. So same point as Peter made. Like, don't necessarily jump into the crazy complex structure right away. Starting with that, I think, is perfectly fine. And what are the benefits? Well, the obvious benefit is you don't run into the risk of having circular dependencies. It's all in the same package. But what are the downsides? Looking at that, do we actually know what this app is doing? There's no mention of beer or review or anything. So looking at that, you kind of see handlers, models, and storage. So that's your basis. That's what you're sort of guessing from. So you're like, well, maybe it's a server, because it's got handlers, and models is probably just some struct definitions. And then storage is obviously, it gives you an idea for, like, this thing probably stores things in memory or in JSON files. But to actually find out what this service is doing, what this app is doing, you have to go into the code and have a look. So if we do just that, yay, setup works. So hopefully you can see this at the back. I can try and maybe make it slightly bigger. No, I think that's as big as it goes. So this is exactly that implemented. So if you look at main, we kind of have some like storage, initializing the storage, and then for simplicity, again, I've just hard-coded it to the memory. Like, it probably should be a flag that you pass in, but for this talk, we don't really care about that. So we've got some storage, and then we call populate beers and populate reviews. And then we set up our router. We define our handlers. So there's like get beer. And then in the main function, so this is obviously the init function, which is the bad thing to do. I've kind of done it on purpose here. And then in the main, sweet and simple, you just start a server, listen and serve. And then if you wanted to find out like what each of these endpoints is doing, like if I try to click through it, it does take me here because Goland is smart enough to work it out. But you do have to actually like dig into the code to see what it does. And then we can see that the get beers one is sending some headers, and then it's going to the database to find the beers. So if we wanted to find out what how the storage works, you have to click through to that. And then it's the encoder here. So it works. I mean, I think for a simple app like this, it makes sense. But again, imagine if you then were asked to like add a client or add more handlers. And so if in this, like currently with 5 endpoints, it's 92 lines, more or less. So if you were to add like 3 more endpoints, or like 10 more endpoints, like the problem with the flat structure over time is that it just grows infinitely. And then you hit the point where you're like, well, I kind of want to split this handlers file into like a bunch of smaller ones. Like imagine testing the handlers file when it has 20 endpoints in it. It's just hell. So at that point, you might be thinking, well, I kind of need a way to group things together. So let's look at grouping things together. The most obvious one is grouping by function. And that probably for those of you, it's also known as the layered architecture because it's essentially got 4 layers. Like this distinguishes four layers. Presentation, so user interface, so your views, and then your application, and then your domain, which is the actual core business logic, and then your infrastructure, so it's like databases, third-party APIs, whatever else. And that sounds like a classic MVC, or like a classic Rails layout. So for those of you coming from those backgrounds, that's probably going to sound very familiar. The obvious benefits of that is obviously that it's easy to decide what goes where. Like, handlers go into one directory, your struct or your domain goes in another one, anything third-party goes into another one. So that structure kind of gives you a bit more of an idea where to put things. But if we look at an example implementation of that, so we've got our layered things, we've essentially got 3 directories here: handlers, models, and storage. So easy to decide what goes where. But then you start hitting some snags. For example, naming. Like, do you do plural or singular? Like beers.go or beer.go? And so sort of like models are fairly easy. But then if you look at main, there it is. This is actually red because like globals start to become problematic. Like once you start splitting things out into packages and you've had this shared state, like the database was in the global, in the init, like now you have to work out like how to pass it into each one, so it just gets a bit more complicated. So at that point, I usually just go like, that just doesn't quite work. It just seems like such a faff now to have to pass it all over the place. And like what actually owns the database? Like where is the file that like owns it? And also this won't compile because that kind of structure has a really, really high chance of having circular dependencies. So if your handler needed to use a model, or like if your model needed to use a storage to, like there's all sorts of crazy things that might happen. So circular dependencies in that kind of structure are very, very common. So for example, if your models, like there is a storage model, which is the generic interface, and that needs to use the actual storage implementation, which is here. But then the storage implementation also needs to use the model to like look up the interface. So you've got all, but they're in different packages, models and storage. So circular dependencies usually sooner or later are going to start biting you. And it's also like fairly hard to extend over time for a big application because it only assumes those 3 places. So again, if you had a lot of handlers or a lot of models, like those 3 directories would just like balloon up with 1 million files in it. Quick switch off the screens. Cool. So are there any other ways that we can group that? Well, we can try grouping it by module. So for example, beers, reviews, and the database. So if I show you an example of that, in our modular case, we've got beers. Maybe I'll leave that one for comparison. So instead of handlers, models, and storage, we've got beers, database, and reviews. And that's actually a point where for the first time, we see some domain names in there. Like we've got beers and reviews. So looking at that structure, you now have an idea of what this app is about, which is a good start. So it gets rid of some of the problems, but not all of them. You still have the potential for circular, I can never say that fast, dependencies. So for example, if your beers need a database, and the database needs beers, so I think I've got an example of that somewhere. Yeah, so to define the storage interface, you need, it saves beer and it takes a beers.beer. So that's a dependency from the database package to the beers package, but then your beers handler needs the database as well. So that's the dependency back into the database package. So again, same problem. And then you're just like spending days trying to work around that. But at least things are somewhat grouped in here, and it's okay, but it's still hard to know when something should be used, like where something should go, when something should be used, like when should you use the functions from the handler. They're not very like descriptive. They're just like get beer, add beer, but then to actually work out what it's doing, you have to look at the code, and you're like, okay, well, it's like defaulting the ID, maybe it's like checking for an existing beer before saving a new one. So there's a lot of things like hidden inside. So the code isn't very intuitive unless you actually read through it. Ooh, back to the... So Are there any other ways? Well, we could group by the context. And this is something that I got really excited about when I first found out about it. And I've only found out about DDD and like really looked into it about a year and a half ago. So I by no means consider myself an expert in this field. And it can be fairly intimidating to start with because it's got like a fairly academic, very defined like language around the model. So it was similar to what we heard yesterday, like just reading the academic papers and you're like, why can't you just use plain English? So this one has a very like official terminology. So it can get quite intimidating, and like don't be worried if it doesn't make sense to you for the first time around, because it doesn't make sense to anybody the first time they look at it. But over time, it actually starts making sense. So when I started using it, I actually really enjoyed it because it seemed like maybe that's the way forward. And then there are two other things which you can couple it with, which is called the hexagonal architecture or the actor model. So I'll mention those two in a minute. So for those of you who's familiar with DDD or who's using it, cool, like 50% of the room. So for those of you who don't know, DDD is basically a design paradigm or a design approach called domain-driven development. So the focus is on the domain of your app. And the domain is essentially sort of the gist, the core logic of like the business logic of what your app is doing. So you first have to establish it. You have to first look at the problem that you're trying to implement or the thing that you're trying to implement, and just ask the question of what are we dealing with here? Like what is our domain? And what is the key business logic? Like what is the key business logic for this service? And then you define something called a bounded context, which is essentially just a boundary within your app for like a logically grouped together unit. So to give you an abstract example, if you were to write a system that handles orders from customers, then one of your contexts could be products, one of your contexts could be orders, one of your contexts could be warehouse, one of your contexts could be customers. And all those things just kind of form separate, completely separate contexts. And then the key thing to realize is that this model helps us to reflect the real life better, because every context is going to have its own definition of the object or the object values or the entities, which is, I think, the official term, that are within that. So, for example, if we come back to the order software, then there's an entity called customer, but a customer is going to have a slightly different meaning in the context of an order than in the context of a product, because in the context of an order, the customer might have things like, does it have priority shipping or Amazon Prime, or is there any special treatment or default discount? Whereas in the context of a product, it could be something like allocation. So like, does this product have a customer allocated to it? Like, has it been sold or is it free? And this is kind of more like real life, because very often when we think about something and like we start talking about it, we might be talking about users, for example. But then as you're talking to your colleagues, depending on what kind of aspect of the app they are looking at, they might come back to you with a slightly different definition of what a user is to them. Like a support person, for example, is going to care about different things about a user than like a salesperson if you were to go and talk to the rest of your company. And this is, I think, a really, really good selling point for DDD, is that it just helps you mimic the real life a bit more by just allowing you to actually group your things by logical like contexts. And there is also something called the ubiquitous language, which is essentially, the main idea is that you go and talk to your colleagues and to the rest of your company, the rest of your team, or to yourself if you're the only developer, and you basically decide what are the names that we're going to use throughout the entire project. And that, again, I've certainly been there where we have a project where 3 years ago somebody implemented like the basic functionality and used these names, but then over time people started using different names, and then you run into like slight inconsistencies where it's not just plural or singular, but actually slightly different verbs for the same thing. And that, again, makes your code a lot harder to understand and a lot harder to read, because looking at this code, you're like, can I assume they are the same things, or are they different? So one of the key principles of DDD is that you essentially just decide and seal your terminology right at the start. And it's like, these are the words that we're going to use to describe our problems, and this is how the world in this app works. And then DDD distinguishes, basically allows you to look at your like problem sphere and then categorize each thing into one of the things listed here. Whoops. So something can be either an entity or a value object. or a domain event, or an aggregate, which is basically the thing that lets you operate on a group of value objects or a group of entities. And then there is services, which just kind of provide some functionality, but without necessarily being value objects or entities. And then there's repositories, which is like data storage type of things, but completely abstract. So it could be relational, non-relational, it doesn't really matter in this case. And there's factories, which let you construct complex value objects or entities and kind of take that complexity away. So again, that helps you reason a bit more about your program because you start to distinguish between like, oh, maybe this is this and maybe this is that. So back to the beer reviews, we could kind of think about that problem in this way. And this is probably not 100% textbook perfect because that's just my stab at it. And like talking to other people, this could probably change because the more people you talk to, the more you refine your domain model. And that's also what DDD is about. It's kind of iterating over that until you arrive at something that you and the rest of your team are happy with. So we could, for example, say that the context that we're dealing with here is an HTTP API for adding beer reviews. Nice and easy. And then the language that we're going to use is beer review, beer repository, and so on and so forth. So you could, for example, have debates around, do we call the repository of beers a beer collection? Do we call it a repository? Do we call it a cellar? And just kind of come up with a crazy name for it. And it's really important to kind of decide on one word and then just stick to it. And then looking at what our models could be, well, the entity is kind of the HTTP server itself. The entity is like a long-lived object throughout your project. It's not just like a short-lived value object that is that kind of may pop up and go, or like you just create those to pass information around and that kind of thing. So I think that in this case, we could treat the HTTP server as our entity because it just lives throughout the app. And then the value objects, the obvious ones are like beers, reviews. And then what kind of events do we have? Well, we can have events like beer already exists, if somebody tries to add the one that already exists. Beer not found. So that's both when you're trying to add a review for a non-existing beer or when you're trying to get a beer and it's not there. And ideally, these should be defined as domain events. But I actually, in the sort of example app that I'll show you in a minute, I've actually defined them as errors. And that's probably not textbook correct, probably not ideal. But again, I like the approach of just take whatever works for you and leave whatever doesn't work for you. Whoops. I don't think it's necessarily worth overcomplicating your structure for the sake of being 100% textbook correct. And also, Dave Cheney wrote a blog post about how you should handle errors, and I've completely did not what he said I should be doing. So again, that doesn't really matter for this project. I just went for simplicity. And then the aggregates, well, we can have a beer adder, a review adder, a beer lister, a review lister. So those are like the things that will help us deal with the value objects and like actually make them do what we want to do. Services, well, add beer, add review, that's kind of your endpoints. The repository is obviously a beer repository and a review repository. And then in this case, we kind of define them loosely. And I'm not specifying, are they in the same storage or are they in the separate storage? Like in this case, we don't have to worry about it yet because we could have one database for both. But you could have, for example, store your beers in memory and store your reviews in the JSON files if you wanted to. So this allows you already for like a lot more flexibility and like a lot less coupling and a lot less assumptions as well. And then the factories, you could have a beer adder or a review adder if they were actually complex things. I've omitted that for simplicity because, again, DDD is not saying that you need all of those in every single app. It's just these are all the options you could have, but if you don't have them in your app, that's fine. So if I switch to the first go at the domain-driven design, so I've kind of grouped it like this. So we've got a package called adding, listing, and reviewing. And basically, we want the package name to communicate what they provide in DDD as opposed to what they contain. So you don't just say, this is handlers, this is whatever. You kind of just try to make your packages tell you a story. And like see, by looking at the structure, you want to know what this app is doing. So we can see already from the names that we can add something, we can list something, we can review something. And then we've got the beers and reviews, which is just our models in this case. And it actually allows us to nicely group logical things together. So previously in, for example, the modular case, when I had the main, the sample data was actually living in a database package. I think it was data.go in the database package, which is kind of not an ideal place for it, because it actually just belongs to the beer, to like the domain and the models, not really to the particular database. But there just didn't seem to be a good place to put it. So I was just like, well, you know, this seems as good as anything else. But here in the domain-driven one, we actually can have a nice and simple separate file for sample beers, where we can just define as many as we want, no logic in there, so that's nice and simple. And then we can have also our like beer struct, so that's the model. We also define errors. So this is where like DDD is slightly different, because you can put different kinds of things together in one file, as opposed to like strictly this file just defines a struct, or this file just defines functions. You can have all of that in one file. So here, for example, we just think about the beer context. So we have the two errors that we mentioned before. We can have an unknown beer, or a beer that already exists. And then we also want to define, in an abstract way, the beer repository. So we want it to allow us to get all beers, get a specific one, or add a beer. And then the same goes for reviews. It's pretty much identical. And then the adding also allows you to split it between the endpoint and the service. So that actually distinguishes between the transport layer and your actual service. So if you look at the service, it allows you to add a beer, and that then talks to the storage. So actually the beer's model or anything doesn't need any knowledge of what the storage is, because it just uses interfaces. And then the endpoints actually, you can kind of have them to make you an endpoint and give it a service. And that way it accepts the specific service and then just creates you an endpoint. So that's purely the HTTP stuff. And you just call the service with add beer, and then you don't need to worry about the logic inside it. But I mentioned this thing called hexagonal architecture, and that's like a one step forward from the domain-driven architecture, because it just defines like the sort of the last bits that you're missing to actually have like a fully nicely working package. So this architecture style, it basically says that changes in one areas of the application should affect as little of the rest of the application as possible. And then it encourages the use of interfaces at the sort of boundaries to basically abstract more and more and more the more outwards you go. So it also distinguishes between use cases and commands. So it actually has commands such as populate the database with the sample data as its own thing. It exists in the model. So you don't have to worry about like, oh, where do I put this thing that I don't know where to stick it or where to name it. But the cool thing about it is that pretty much the only rule you need to remember about is that the dependencies are only allowed inwards. So the core domain cannot depend on anything outside of it. So it can't depend on your application, on your framework, or your storage, anything else. Your framework, however, can use the application things, and it definitely uses the core domain and the domain to like make itself work. But that essentially guarantees that you're not going to have circular dependencies, because the dependencies will always flow inwards and in one direction. So how do you put it all together in Go? Well, Peter already mentioned the top-level directories, command and package, and I've linked to his blog post here. It's a really, really good blog post, like one of the basic ones to read. And then another one is the Ben Johnson's blog, which Peter also mentioned. Like those two blog posts pretty much sum it up, and they kind of talk about DDD and hexagonal architecture without naming those two things, but that's essentially very much aligned with those things. So this is just a summary of that, if you like. So you have your top two directories, commands for binaries, and package for the rest of your code. And then you've got any other project files that you might have, such as builds, Docker files, package manager files, whatever, that just sits in the root directory. And again, it's nicely separated from the rest of your code. And then your domain types are at the root package. Your dependencies are all in the subpackages. Mocks are recommended to just have in a shared subpackage. Like there's not really a good reason to have a mocks package within your every subpackage. Like it's fine to just have them in one shared one. And then the main just brings it all together and initializes the app. And again, doesn't disagree with the rule that you avoid global variables and init, because it kind of gets rid of those things. Because you've got everything grouped into sub-packages, you pretty much have no need for global state, which is really nice. And then, if I show you the app with sort of the final stab at it in here. And by the way, I'll put all these examples online because it probably makes more sense for you to go in your own pace. I know it's like a lot to take in one go. So we've got our command top directory, and we actually can have the data populating as its own command. And if you look at main, it's nice and simple. And then you can have the server, which is another sort of entry level into your app. And that's slightly longer. So to compare the two, the data only initializes, it initializes the storage as well, but it only has the beer adder and the beer reviewer, because it just needs to add things, whereas the main server is also going to have a lister. So again, you can kind of group those things and keep them independent, and you can change one without affecting the other. And again, it's just like initializing the storage, initializing your services, so your adder, reviewer, lister. And then you can, I forgot to remove this, but you don't necessarily need it here. You can kind of run it as part of the main server. You can just leave it out and call it whenever you want. And then the HTTP setup is pretty simple, except for you're now just asking your listing service to make you a get beers endpoint. And just even reading through this code, it kind of tells you a story. Like the names are a lot longer, and they probably could be improved slightly. But if you see this code and you're like, OK, make a get beers endpoint or make an add beer endpoint, you kind of know what this code is doing. It tells you what the code is doing, which is really nice. And then I've left all the storage, which is kind of the actual implementation details for memory or JSON, in a separate package. So again, I could add a MySQL here or Cassandra or whatever it is without really affecting anything else, because it will use the same interface. As long as it uses the same interface, I can swap in and out. And I've got the package, which is the core of the app, which is very similar to what we saw in the previous one. So adding, listing, reviewing, and then the beers and reviews. So overall, I think looking at this, I think it's just nice and sweet and simple. And it kind of makes sense. And it's easy to extend, add, remove, delete, without really affecting everything else. Like all the logical layers are grouped together and fairly independent. So there is a slight shortcut for this. There is something called Go Build template, which is actually, it gives you a makefile and Docker file for your Go apps, but it actually uses the command and package top level structures. So if you clone that, and if you wanted to like start your app with that, that's going to encourage that structure. So it's already becoming like a new industry standard, I think, across many, many projects. The actor model, I'm very quickly going to touch on this. I'm not going to spend too much time on this because I'm not actually that familiar with it. It's kind of a new thing, but it sounds really interesting in the context of Go, because basically the idea is that every object is an actor, but all communication between the actors is performed asynchronously, and it's stateless. It's completely stateless, which, if you think about it, no shared state, well, that's like right up the alley for concurrency. So the creator of, well, not the creator, but the main guy behind DDD, von Vernon, he said that it's well suited for DDD and highly scalable systems, and potentially simpler to implement than a typical event-driven architecture. So I'm very curious to look into that myself. I haven't had a chance yet, so I'm only mentioning it here in case you wanted to have a look. But it sounds like a good alternative. I think it's still an emerging pattern more than something we know very well. And then just a quick note on naming of the packages. Pretty much all the basic Go rules apply. So I've linked to a talk here that runs you through the naming conventions in Go. The gist of it is choose your package name, like make them descriptive. Basically, make them tell you what's inside. Avoid generic names like utils or commons, because they just become bins for just like the general umbrellas for everything that people stick in because they couldn't find a better place, and it doesn't give you any clue what's inside. And then avoid stutter if you can. Like if your package is called, like your package is going to be repeated when you use something defined in that package outside of it. So just like the obvious example is if you have a package called string and then you've got a reader struct, maybe don't call it string reader, because then you've got strings, string reader, and that's the stutter that maybe it's good to avoid. And naming is hard. You know, it's one of the 2 hard problems in computer science, naming time zones and off-by-1 errors. So, and then testing. I haven't spoken about that much, but testing is pretty simple in the DDD context, in the DDD kind of idea. I tend to keep the test files still with their files. I don't think there's much point having like a copied structure for your tests. So like the exact layout, but with tests inside, I don't really see how that would give you any benefits. So I just tend to stick the test files right next to the files that they correspond to. And like I said before, a shared mock package is a good idea. So just to wrap up, I think first and foremost, definitely always look at your design. Don't be afraid to judge it. Look at the common existing ways to structure a project, and it's something that sort of Peter was talking about as well. Like, none of these structures is bad. I'm not here to tell you, like, don't use this one, use definitely this one. All of them have valid use cases. So think about your project and what your use case is and what will work best for you. Prototype, by all means, that's probably the best way to get comfortable with different layouts in Go. Just have a few silly apps on the side, like kind of the example that I made here, and then just see how it works. I really like this quote, "Be like water," that was coined by Bruce Lee. And that's basically, the idea behind this is that you should almost expect things to change. Like, don't expect to just nail your structure once and never ever change it again, because you're very unlikely to get it right the first time. You're likely going to have to evolve it over time. You're likely going to have to adapt. You're going to hit some obstacles. So just be like water and just work around those obstacles, but kind of almost look forward to them. And then again, don't feel bad if you don't get it the first time around. Like, I still struggle with getting DDD right, and I've been trying to do this for like a year now. And those good choices and the practices will mostly come with experience. So the more you play around with it, the more projects you write, then you're going to work out your own good habits, like things that you like doing. And then don't forget to share them, because that's how we all benefit as a community. So like I said, no single right answer. All of these are valid. Just remember to try to group your packages by context rather than just the functional type, the traditional MVC. Avoid global scope. It will help you out in the long run. If you can, separate your project code from the main binaries, unless it's a simple app and you don't have a need for it. And above everything, maintain consistency. Whatever structure you come up with, just make sure it's consistent. Make sure that if you refactor a part of the app, you kind of bring the rest of the app in line as well, because that's one of the most important things. And then I've listed some references here. If you want to have a look more, there's some blog posts, some videos. Marcus Olson is another guy who's, he's the one who ported the classic Java DDD example app into Go, and he tried to demonstrate how you could do that in Go. And that's a really cool talk to watch, and he has also got like a 3-part series blog post on it. So that's really cool, because he just walks you through the reasoning behind it. And then the slides and the codes are all up on GitHub. They should be by now. And I've also tweeted the links. So if you want to go back and actually look at it in your own time, you're more than welcome. And if you have any feedback or questions or comments, or if you want to chat more about it, then by all means, either grab me afterwards, because I'll be around, or tweet me, or I don't know if there's a social tonight, but if there's a social, then again, come and chat. Come and have a chat. So that's it. That's it for me. Thank you very much